All right, so part two here. Let's talk about this. Because voltage is a confusing concept. So let's say we have all these different batteries here, a D, a C, a double A, and a triple A. You may have all of these inside your house. Well, all of these batteries, if you looked on them, they're all 1.5 volts. And that confuses a lot of people. How can these different things be all the same voltage? Seems like the bigger they get, the more voltage they should have. Well, if you understand what they mean, first of all, this means that, all of those batteries give 1.5 joules of energy to every coulomb of charge that's in them, every single one. So, what's the difference here? The bigger batteries have more overall charge in them. And because they have more overall charge in them, they therefore have more overall energy. So you can sort of think about this because voltage will become analogous to pressure a lot in this chapter, that these are different tanks of water and they're all giving the water the same amount of pressure, the same amount of push for that water to get out of there. But the D cell here would represent a bigger tank of water. So it would last longer if you put it into the same device here. There's other differences too, like how fast they can let the charge out. D's can let the charge out a lot faster than AAA's can, but we're not going to focus on that as much. Here's another example to try and help you understand voltage that can be confusing. If you rubbed a balloon on your hair, like we talked about from the last chapter, then you could get a million electrons deposited on that balloon and raise the balloon to an electric potential of 5,000 volts. So, isn't this dangerous to have a 5,000 volt balloon? No, clearly not. No one's ever been killed by a balloon. So why not? Because in most cases, if you see danger, high voltage, most of the time, high voltage is dangerous. You don't want to mess with it, but not in this case. So why not? Well, even though the energy per charge, that's what voltage is, 5,000 volts means there's 5,000 joules of energy for every coulomb of charge on that balloon. But there are actually a million electrons. It may sound like a lot, but in terms of number of electrons, it's actually hardly anything. That's hardly any coulombs. So even though there's a high amount of energy per coulomb, there's virtually no coulombs and therefore virtually no energy at all. So we get the word volt, by the way, by this gentleman right here, Count Alessandro Giuseppe Antonio Anastasio Volta, and he is the inventor of the dry cell battery. So here's a painting of his battery. Here's a replica of it right here. So the very first battery was invented by Volta here. This, by the way, over here is Napoleon. So Napoleon had just conquered Italy at the time that Volta was making this battery here. It's also famous for statues of babies in flower pots. Here's an early Volta work valued at $10 million here. Let's finish with an analogy on this video. Water on its own would want to move from high pressure to low pressure. So let's say we had a big, tall tank of water and a shorter tank of water, and we connected the two with this pipe. So this side would be high pressure, and it would flow over to the low pressure side. If we say this in more physics words, the water would move from a high gravitational potential energy on this side to a low gravitational potential energy on the other side. So in order to get water to do this, we need a pump. The pump creates this pressure. Said in other words, a pump will move water from low potential energy on this side up to high potential energy on that side. So a battery is very similar here. Charge wants to flow from a high voltage to a low voltage. Or say that in other words, from a high electric potential energy to a low electric potential energy. A battery creates voltage, and that's what we use it for. If we say this in more physics words, the battery moves charge from high potential energy to from low potential energy to high potential energy. And that's the function of a battery, to give charge energy, and then it is going to start to flow eventually when we start to talk about current. This is the end of part 2.